Hi, Ron. Glad to see you here.
So we are 22 so far, and this is our 15th in the series of CAWASA's webinar series, Water Loss Control, this afternoon with Carl Yates. I will just give another couple minutes so we can introduce Carl. I have a bio here. I don't know if you want to do that yourself, Valerie.
Oh, no, you can, and then I'll maybe add a couple of things afterwards, but you've got the notes right there.
All right, great. And I will allow Carl, I will stop sharing and I'll allow Carl to share his screen. Let's see. So, okay, Carl, you have your, you can share your screen whenever you're ready.
Can you see what's in front of you now?
Can only see you.
Okay. Let's see, I'll go back again.
There we go.
You're going to see my screen now.
Yes.
Yeah, got your whole screen. Yeah.
Yeah. I won't pop up the presentation quite yet, but at least you'll enjoy my desktop and the busyness around it.
All right,
so,
good.
Yeah, there's where most of us like to see the ocean, nice and calm, and we can run along the beach. I already had my run today, but it wasn't along the beach. It was along the shoreline to check out all the wave action with the.
Oh yeah, with the storm.
With the storm, yeah, we've got a lot of surfers now that have congregated in some of our shorelines of Halifax area. They're having a great time now, riding the waves.
All right, keep safe. Okay, we have.
I don't see anybody else coming in right now.
Okay, yeah, we'll make a start. So, this is, as I said, our 15th in the series of CAWASA water operators, as they call it now, Wednesday webinars. And we are pleased to have with us Mr. Carl Yates, who has extensive experience in water utility profession, having served as project engineer, chief engineer, and general manager of the Halifax Water Commission from 1988 to 1996. In 1996, he was appointed general manager of the Halifax Regional Water Commission, which assumed a regional mandate after the municipal amalgamation of the Greater Halifax area in 1996. In 2007, Mr. Yates oversaw the formation of the first regulated water, wastewater, and stormwater utility in Canada, with the transfer of wastewater and stormwater assets from the Halifax Regional Municipality. After retirement from Halifax Water in July 2019, he formed his own consulting company to promote and support sustainable water management. Mr. Yates obtained a Bachelor of Engineering from the Memorial University of Newfoundland in 1984 and a Master of Applied Science from the Technical University of Nova Scotia, now Dalhousie University, in 1992. He is the past chair of the Focus Area Council of the Water Research Foundation, vice chair of the Canadian Water Network, and board director of the Alliance for Water Efficiency, and a past member of the board of directors of the Special Olympics of Nova Scotia. So we have a well-decorated presenter this afternoon, and I trust that you will thoroughly enjoy the presentation and take copious notes. Over to you, Mr. Yates.
All right, thank you, Ignatius, and I'll be pleased to pull up my presentation here.
And while you're doing that, I will just say that Carl he failed retirement, and he has recently been appointed as the Chief Executive Officer of the first water authority, water and wastewater authority for the whole of the Maritimes. And if you think he talks a little bit funny, that's because he's from the Maritimes. If you need a translation, we'll translate.
Oh gosh, and I thought you talked funny, Valerie, so there you go.
I do. But Carl is, I have to tell everybody that he is recognized as probably the leading utility manager in Canada. He's on every committee going, always willing to give his time, and I'm just delighted that he's taking this time to be with us today. Thank you.
Yeah, we highly appreciate that.
Okay, well, if everybody's, I guess, strapped in for the next hour, I should get started. And again, it's a pleasure to be here on behalf of Operators Without Borders, and had the pleasure certainly of working with them over the last 2 to 3 years. So we're going to talk, of course, today about water loss control, and in particular, a new way of doing business to reduce your leakage in your system. But first, I guess, as we say, a word from our sponsor to recognize that we are doing this on behalf of Operators Without Borders. And normally, of course, our prime focus is to help developing countries recover from disaster situations, which we know will not stop with or without COVID. But with COVID now, we're going to turn our attention more to building capacity through training and mentoring water and wastewater operators from afar. So doing webinars like this is the best way we can still reach people and fulfill our mission. So let's define the problem first. You know, is there a problem with leakage? I pull up some stats here from the United States. The Geological Survey estimates that there's about 1.7 trillion gallons of water lost from distribution systems every year. So that's hard to get your head around that amount, but nonetheless, it's equivalent to the top 10 United States cities in terms of their consumption. So that's a lot of water. So one has to ask the question, you know, why is it not being fixed? You know, is it, we're just waiting for it to come to the surface? Are we in denial? Or are we waiting, I like to say, are we waiting for the leaks to find us? And sometimes they will. They'll blow up your street if you let them. So there's lots of ways, I guess, we can find the leak. But I think really most of this leakage is not being reported. In other words, it's not coming to the surface. It's staying underground and leaking away, you know, through other sewer systems or into the groundwater. Otherwise, I think we'd fix it, or I certainly hope so. To bring it down to a more micro level, as Valerie mentioned, we've been working with Pignon, Haiti, and they've got an interesting project where they want to reduce their non-revenue water. And there's just a little slide here to show you the context of what we talk about when we say non-revenue water. Some of that non-revenue water actually is authorized. You'll see it used for firefighting or for flushing or for construction. Still authorized, but not necessarily drawing any revenue for the utility. We've got apparent losses that are associated with meter inaccuracies, illegal connections, in other words, theft of water, and we have data handling errors as well. But in terms of what we're going to talk about today, we're going to really focus on real losses. This is the leakage through the pipes, through tank overflows or tank leakage, and background leakage. So we'll move into those categories, and I'll explain a lot of that with the new methodology that has been used extensively, I think, over the last 20 years. Or at least I should say Halifax Water has been using it extensively over the last 20 years. So just a little note there to give some context again to Pignon. They have a total supply volume of around 25,000 gallons per day. They actually get revenues for about 4,000 gallons per day. So you can see the problem right away here. We've got 21,000 gallons at nobody's paying for. So when you do the math and you look at a percentage, that comes out to basically 84% of the water that is supplied to the community is not being paid for. So I want to pause here just to say, you know, there's many on the webinar today that probably work with a small system, and it would, you know, be interesting to know what everybody else's lost revenue is. And I'm sure there's quite a range, but in North America, we certainly see that quite high. I can even tell you in Canada, there are some cities that would still have this in the 50% range. So this is not just foreign to Pignon. This is a worldwide problem, but nonetheless, we're pleased that Pignon is going to try to tackle it. So I promised a look at a refined approach for water loss control. There's some good news certainly to share. This is again a world problem. So back in 1998, the International Water Association put together a task force to look at the problem and develop a new methodology to basically tackle it. So over a 2-year period, this task force developed this new methodology, which I'm going to speak to today. I can also say that at that time, it did include a rep from the American Water Works Association. So we were pleased to see that because that gave it, I guess, a opportunity then to bridge the differences between what was going on in Europe in particular and in America. And I want to focus on North America because that's where most of my background comes from, where I've seen some issues in the past and some difficulties trying to control water loss. And basically what we saw for the last century really was a focus on what we call unaccounted for water, to really try to find leaks in a very ad hoc manner, I can say. And really what we saw, there was no real significant advancements in North America before this AWWA methodology came on the scene. I would suggest that there was more than shortcomings. There was no standard approach, and I even tormented some of my American colleagues by saying they practiced voodoo and witchcraft in order to show to some regulator that they were making progress, when really they weren't. They were actually in a state of disinformation. So in terms of managing real losses, the foundation of a successful program is to make sure you have a proper water balance to start. And that is basically a water audit to try to determine, you know, where your water is going, how it's being used, how you account for it. You should also recognize that when you're doing this water balance, you have to make sure that the data you input into your audit is based on good data. And obviously, if you put in things that are false or misleading, you'll hear the phrase garbage in, garbage out. So one has to be careful when you're doing your audit that you recognize there's a level of confidence with the data that you use. Should point out that the IWA and now the AWWA methodology, because now it's been adopted by AWWA, uses 2 key performance metrics, the most famous being the infrastructure leakage index, another one basically measuring real losses in liters per connection per day. But I show you the basic calculation here for the ILI. It is the calculated annual real losses over the unavoidable annual real losses. The calculated annual real losses is developed through this water audit, and it is a definite technical measurable amount. And the unavoidable real losses come from an empirical formula based on the length of the mains in your system, the density of your connections, and the pressure that your system operates under. Suffice it to say, if you have a higher pressure in your system, you're allowed to basically have more allowance for unavoidable real losses, which makes sense. And I'll show you some of the pressure leakage relationships as I go through. So here's the pretty picture I wanted to show you. This is the IWA standard water balance. And what we like to say about this balance is that there's a place for everything and everything in its place. So it's really flipping this whole concept of unaccounted for water into accounting for every volume of water that's pushed through your system. So you start on the left with the system input volume, and on the right, you've got the final calculations for revenue water and non-revenue water. And obviously what you're trying to do is to reduce your non-revenue water as much as you possibly can. So there's several categories you can see in the screen here, and I won't go through all of those in great detail, other than to show you, remind you of the parent losses in particular and the real losses. And again, we're going to speak about real losses today, predominantly leakage within the distribution system, which is really where the action mainly happens. And that includes both, of course, your main pipe and the service connections into your customer's premise. And I should point out there's massive spreadsheets to go with this water audit, as you would expect. And once you get familiar with the spreadsheet, you can refine it and tweak it and set targets for yourselves and really set a performance level that you want to pursue. So here are the 4 strategies for reducing real losses. We've got pressure management on top here, and you can see it can change. As I mentioned, if you increase your pressure, then you can get changes in leakage. So that's why the arrow goes in both directions. You have speed and quality of repairs, and that means making sure you go repair a leak once you know and you're aware that a leak exists. Also have active leakage control. That's doing all those surveys that you should do on a consistent basis. And at the bottom, you'll see the asset management piece to reduce losses. That's more of a long-term strategy where you make your capital improvements, you upgrade your leaking pipes when they're beyond their useful life, and making sure that you select good materials for your renewals. So I mentioned earlier about the infrastructure leakage index. You're trying to basically, it's a ratio of the calculated annual real losses over the unavoidable annual real losses. In a perfect world, you would have an ILI of 1. Now, there's not many perfect places in the world where you should get an ILI of 1. I can think of some countries where water supply is limited, places like Australia, South Africa, Israel, and yes, some places probably in the Caribbean where water supply is precious. But in other scenarios, in Halifax water, for instance, we would look for a ratio of around 2.5 to 3, because that was closer to what we'd call our economic level of losses. So most progressive utilities push for that economic level of leakage. So you allow some leakage, but you certainly want to make sure you're getting your money's worth and at least are cost neutral when it comes to leakage control. I'm going to speak in particular about leakage runtime and make a note that there are 2 of these strategies that absolutely have an effect on leakage runtime. And I'd like to start by talking about active leakage control. If all you do is do leak surveys, which many utilities do, if that's the only thing you do, you should do them on as a frequent basis as you possibly can. For utilities that, for instance, that would only do it once a year, you can expect that your average runtime for a leak would be 6 months. Because if you're only looking for leaks once a year, you can appreciate that if you find 20, then most likely on average, they could be running for 6 months, which is indeed a lot of water lost. If you want to do some more reading, this is what we refer to as the Bible of water loss control. This is the publication put out by the American Water Works Association, M36 Manual, Water Audits and Loss Control Programs. So if you haven't bought your copy yet, I encourage you to buy one, get involved with any training through AWWA, because you will then take control of your problem by getting the training that you need. So talk a little bit about leakage before we move into some of the details about leakage runtime. There's really 3 types of leakage, and this is described in many of the best practice manuals. Over on the right here, we talk about reported leakage. These are the easy ones to find. These are often reported by the public or by utility workers. And there's lots of tools to keep the leakage down, including pressure reduction, asset management, replacing mains that are leak prone, and optimizing your repair times. If you move over to the center, you'll see the unreported leakage. These are ones that generally don't surface. You don't see them, but they are still detectable using traditional acoustic equipment. And that's important. These are the ones that you spend most of your time on if you're a progressive utility. These are the ones that will skin you alive if you don't find them early. A lot of the tools that we use are, again, pressure reduction, again, that long-term strategy of main and service replacement, reduction in the number of joints and fittings. You get a lot of weeping, obviously, and leakage at joints. And again, proactive leak detection, to really be looking for them way ahead of when they will find you. And over to the left of the screen, we have background leakage. These are unreported and generally undetectable using traditional acoustic equipment. They're very small. They're the weeps at the joints. They're the ones you're not going to see. They're not economic, actually, to go find. So there are still tools, however, you can use to reduce background leakage. Again, pressure reduction is a tool that works for all three. Again, you replace older mains with your normal capital program, and again, reduce the number of joints and fittings where a lot of the leakage occurs. So those are the three types of leakage to understand. But really what we're really after, if you're going to be a progressive utility, is going after the middle one. The unreported leakage is the one that gets most utilities in the end. So I mentioned about leak runtime awareness and how important it is, and this is a very famous and simple graph for people to get their head around. Leak runtime consists of three segments of time. One is awareness. So in other words, do you actually know you have a leak? And this is usually the longest amount of time in the equation. Leaks sometimes run for a long time before they are I guess detected or seen. Once you know you have a leak, you send a crew out to locate it using often acoustic, digital, or other ground microphone techniques. And then, of course, you have to organize a crew to dig the leak and repair it. And each one takes time. So the shorter you can reduce the time frame, the better off you're going to be. And to illustrate that point, here's actually two leak sequences that we had in the system in Halifax Water. And I want you to focus your attention first on the bottom left for a big leak. That's an obvious big leak, and you can clearly see it on the screen. This is a screenshot from the supervisory control and data acquisition system, the SCADA system. So this is measuring, the SCADA system measures flows and pressures in real time. So this leak here that you're seeing is 200 cubic meters per hour. It's a big leak, and we got an alert through our normal reporting procedures. We actually have alarms set on many of the systems that actually one of our operators got a page on their phone and quickly looked at the screen and knew where to go look for that leak, believe it or not, and went out and shut it down. So in 1 hour, that leak was controlled. But that's not your problem leak. It's a real big leak indeed. But look up the number up in the top right-hand corner now. You can also see a leak in this system. As a matter of fact, you'll see a leak over a 9-day period. And I want to explain what you're looking at there for those perhaps who are not familiar with SCADA graphs. But you'll see a nice repetition. These are the diurnal repetitions of water use in a specific zone in the distribution system of Halifax Water. And I want you to pay particular attention, if you look closely at the bottom left of this screenshot. Okay, so looking at the top, again, corner right, looking at the bottom left of that screenshot, you'll see some of the low points of usage. And that's, of course, night flows that we can clearly see water is not used very much at nighttime. But you can also see what happens over time. All of a sudden, there's an increase in night use, or night flow, I should say. It's not really use, it's actually night flow, which actually means more likely there's active leakage. So I'm actually showing you something that's actually not good, because you can see this leak ran for 9 days. But I also want to explain to you that after, about day 2 of normal performance in this area, the superintendent went on vacation and he left somebody else in charge. He came back after 1 week and was very upset because he quickly looked at this screen and said, get out there and fix that leak. And they went out, found the leak that day, and set up for the next day to fix it. And you can see exactly what happens. So you look to the right of this graph, and now you can see that the leakage is back under control. So now we're back to the normal night flows that we would expect. So you can clearly see a 9-day leak. So now when you look at the difference though in terms of volume, this leak lost 5 more in terms of 5 times the volume of that leak that only was going for 1 hour. And again, to say this is the leak, this 9-day leak is the one that will skin you alive. There's still a lot of utilities that don't find these small leaks. This is only 5 cubic meters per hour, but they can be found. So managing leak runtime. So the key to managing leak runtime to reduce real losses is indeed the critical thing you need to focus on. And not only that, though, is the willingness to repair leaks. Once you find a leak or detect a leak, you have an obligation to repair it. Find the leak early, find the leak small is the mantra for water loss control. So how do we find these leaks that are small and under the unreported category? They're found using district meter areas. There's a lot of progressive utilities that have adopted this strategy, and is certainly a best practice in the world now. Extensively used in the UK, some utilities in Canada and in America, extensively used in Australia, Germany, Austria. Many countries have adopted this methodology. So DMAs can provide the awareness of leakage in near real time because you're monitoring your system, of course, through SCADA. And that's part of this whole approach as well, that you need to have a robust supervisory control and data acquisition system. So it's monitoring pressures, flows, and the like, and levels, tank levels throughout your entire distribution system. You break up the DMAs, your zone, or I should say you break up your distribution system in manageable zones, these DMAs, in kind of smaller systems that you can send a 2-person crew out a lot of times to find a leak in a couple of days by acoustic leak detection. So that's generally what I've seen work well. You should be able to find a leak within a couple of days within a specific DMA if you've got a 2-person crew. This also allows you to continue to monitor your flows and in particular pay attention to what's happening between 3 and 4 in the morning, because that's when, again, most people are not using the water. And you can set targets based on that minimum usage in your system. And of course, to throw in another adage, if you can measure it, you can manage it. And that really is what this is all about. Measuring flows, measuring where the water is going, measuring how much is being used, and then chasing the low-hanging fruit where you can find that exacerbated leakage. So here's an example of a mature system. This is Halifax Water's distribution system, and I don't expect you to read anything on this chart. I want you to pay attention though to the different colors, of course. It's a pretty chart, a lot of different sizes and shapes, so you'll note that each color represents a distinct DMA. And in Halifax Water, there's around 1,500 kilometers of main, and this is roughly 75 DMAs that you see in front of you on this screen, discrete DMAs. So again, they come in all shapes and sizes. So often people talk about size, size, yes, does matter, but in many cases, it is opportunity driven. In many cases, the size can really be predetermined. For instance, if you've got a boosted system, that is an automatic DMA. You also might have some existing pressure zones that are the right size for your resolution and your leak detection for a couple of days with the 2-man crew. So some already exist in your system. They're right in front of you in many cases. In some cases, you will have to break them up into smaller zones so you get better resolution. Is smaller better? The answer is going to be yes if the opportunity exists, because you will get better resolution and you will get reduced leakage runtime. But again, your DMA is based on many factors, including your acceptable leakage runtime and your night flow analysis. If you don't have a problem with your night flow, don't break up your DMA. If you're only seeing very low flows in the nighttime, there's no reason to break up your DMA. But typically what we see in many utilities is a DMA usually consists of around 30 kilometers of pipe, which is about 200 hydrants and about 3,000 service connections. So here's a typical DMA in the Halifax water system. And this is a boosted zone. So I mentioned, of course, it's a natural zone, an easy one to delineate, but also important to recognize that boosted water is usually your most expensive water. So as a result, Halifax Water pays a lot of attention to this because actually this is the most expensive water that they produce because it's boosted actually 3 times before it reaches the customer. So you'll see in the bottom right-hand corner of this screenshot the attributes for this DMA, around 27 kilometers of pipe, around 155 hydrants, and just shy of 2,800 service connections. I want you to look at the top right-hand corner again. You can see a SCADA shot for this zone, and you can see on the screen the scale, which is in cubic meters per hour, and it's broken up to 0, 50, 100, and 150 up on the y-axis of that screen in the right-hand corner. And you can see that night flow I keep talking about, and you can clearly see that the SCADA system is showing you a night flow of around 20 cubic meters per hour. Just below that graph is our calculated minimum night flow. We do calculations for what we think should be happening in our system. This is based on, of course, metered usage for our customers, and estimates for commercial users. And we're showing that our minimum night flow says it should be just shy of 19 cubic meters per hour. So based on that, we can assume that this is a very tight system. So we would not be worried about looking for leaks here. This is a tight system, and we walk away with a smile on our face. We don't have to send anybody looking for a leak here. We've got a very, very tight system, and we're pleased. And I want to blow this up a little, I guess, for people to see. There's much more you can do with this data as well. You can get a real sense of what's happening in your system. So this is a 3-day period for that same DMA I just showed you. So on the bottom, you can clearly see the diagonal curve repeating itself over a 3-day period. And I always like to tease the audience with this one as well, because you can clearly see that one of these days is not like the other. These are 3 days in a row. 2 are almost identical. It's amazing how exact they are in terms of repetition. And I guess not to prolong this, because we've only got so much time for presentation, this is a Sunday, Monday, Tuesday, I guess, usage pattern for this particular DMA. And you can see Monday, Tuesday is the two to the right. They're identical. People are getting out of bed early and having a shower and going to work. And of course, you can see the Sunday crowd on the left of this screen here is sleeping in. And you can see the pattern is very different and easy to detect that it's a different day. So I mentioned sometimes you might have an area of your distribution system that's too large for good resolution and refinement for leak detection. So I want to show you what Halifax Water did for one of its areas on what we call the Halifax Peninsula. So this is the heavily populated area of Halifax. So we had a DMA to start of 114 kilometers of pipe, about 600 hydrants, and almost 9,000 services. So I mentioned earlier that 3,000 services is not a bad benchmark to shoot for. So that tells us maybe we should try to divide it by 3. Let's see if we can break up this DMA. I often say breaking up a DMA is like, and to find a leak, is like finding a leak, is like finding a needle in a haystack. Sometimes it's very difficult. So we always say a better way to find the needle in the haystack is to break up the haystacks. So instead of having now one big haystack, we'll break it up into 3, and we'll use our other tools to find the needle. So I like to use that analogy when I'm looking for leaks. It's like sometimes finding a needle in a haystack. All right, so here's what we did. We dropped in 3 master meters, and we closed some boundary valves. Yes, indeed, we actually closed valves, so water was forced through 3 areas, and you can clearly see where they're forced through there through meters. So now we have another clean DMA with 32 kilometers of pipe. We drop in 2 meters in the north end of Halifax, and voila, we have a second DMA of 36 kilometers of pipe. And again, closing a lot of boundary valves, so we got a very tight DMA, no flow through across the valves. And by default, we have a third DMA. So those are the distinct DMAs now that Halifax Water now uses, and they're able to find a lot more leaks as a result in a shorter period of time. So here's a standard flow chamber. It's not rocket scientists putting this together. This is pretty standard, just a basic meter chamber with a mag meter dropped in. You can see this is actually a meter that's designed to be, I guess, flooded. If there's groundwater, it won't hurt that meter. There's also a tap there for a pressure meter, so we can determine pressures there as well. And we put a remote terminal unit nearby on a telephone pole that sends the signal back through our SCADA system to be received in the usual manner. So you can see that bottom right-hand shot, a very simple installation, remote terminal unit panel up on the pole, and you can clearly see the antenna to send the signal back to our headquarters. Total cost in Halifax, Halifax is roughly $25,000, so a very good investment. I should point out that the leakage that we found with these minor capital upgrades paid for itself within 2 years. So it does not take long to get sustainable results. So I also mentioned, of course, about active leakage control, doing these surveys on a regular basis through your system. This is still a traditional approach, still works in a lot of utilities, and we use it in Halifax Water initially. We rely more now on, of course, the DMA approach, but nonetheless, we always do leak surveys at least once a year, in the spring of the year in particular, after we do our flushing of hydrants. So this is still a practice in Halifax. So when I say the noise mapping approach, I want to explain what that is. First of all, we use a lot of the traditional equipment that many of you probably are familiar with. These are ground microphones that we can go out and attach to any appurtenance that is connected to the water system. So that could be a hydrant or a valve. And of course, in Halifax, we can do this in all weather. So you can see in the right-hand side, obviously that's not something that you folks in the Caribbean would see very often, but it is obviously a regular occurrence in the north. So we start with a very simple basic map. I'm just showing we actually started with maps of our system, and our operators would go out and sound every hydrant and valves and listen with the ground microphones and try to basically put in a figure for how loud the noise was. And we had a range of 0 to 100. Anything that's screaming, that's really loud, sound like you got a serious leak, then that's 100. If everything is quiet and silent, can't hear a darn thing, then that's a 0. And they use a scale in between. And we teach our operators over time to basically calibrate their own hearing to that scale, to try to understand what's loud and what's quiet. There's a little blow up of that, so you can clearly see the labeling there. And obviously where we've got some leakage, they've even got a nice little color code. Red, obviously, is a problem area. Green is not. So you see everything circled with green, and you can see where they went back over things. And you can see a lot of 100s popping off the page there next to some hydrants. So we actually went back in after this leak survey and found actually 2 leaks in that area. So that's how noise mapping works. It is exactly that. You use a map, listen, and just simply record your interpretation of noise levels. And of course, it does take time. I won't say this is a simple thing that people get used to. The more senior leak detectors are really good at it, and they, of course, mentor the junior folks to become good at it over time. We obviously just plug a lot of this information into spreadsheets, and we can talk about leaks that should be repaired. We pinpoint where they are by address. Sometimes we'll bring in a digital correlator to pinpoint if we're not quite sure based on the ground microphone. And then we go back and repair it and then do a recheck. So often, you want to make sure that you repaired it and you repaired it well, and you go back and check once the crew is finished with repairs. And you'll even see some comments on the right-hand screen. Sometimes we'll hear transformers that cause noise and are therefore not leaks at all. But worth investigating. Assume nothing is the mantra that our leak detectors use. So I'm just going to show as well where you can extend the benefit to your customers. Often customers have their own unique internal distribution system, and they have the opportunity to stem leakage and be good stewards of their own water supply. So we actually worked with many of our customers to help them reduce water on their own internal distribution systems. So here's an example. We worked with the Port of Halifax. We told them that we could help them reduce their leakage by monitoring in real time at their points of sale where we actually sell them the water. We could hook up flow monitoring equipment to SCADA to show in real time what's actually happening in their system. Now, you might say, why would we bother to do that? Because we could still sell the water. As some accountants sometimes say, happiness is a metered leak. But we felt, no, we shouldn't do that. We should be good stewards and we should work with our customers so they don't waste water. So here's an example. We work with our customer and put on a monitoring device on their meters. And monitor, of course, in real time through SCADA. So here's our initial offer to help them. And this is a 24-day graph. And I want everybody to just relax a bit and take this in. This, and again, on the x-axis, you can see several dates, but this is actually flows over a 24-day period. And on the y-axis, you can see some different flows. They're actually broken up into cubic meters per hour in 50. So it's 50, 100, 150, 200, and so on in cubic meters per hour. Again, I like to have some fun with the audience here. I often ask people to point out how many leaks can you see? And of course, for the untrained eye, many of them look at all these peaks and count them as leaks. So you can quickly go through, and some people might say, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, there's at least 10 leaks, I've often heard people say. And the answer is no. There's only actually one leak on this graph. Those big spikes that you see are cruise ships taking on water. Many cruise ships come to Halifax because we have one of the highest quality waters in the eastern seaboard and actually lowest price waters. So they get bang for their buck when they fill up in Halifax. The leak is in the center of the graph, and you'll note there, around, I think I can see there, August 13th is when we can say that the leak started, and the leak was stopped actually on August the 23rd, but it ran for just a little bit less than 10 days. And you can clearly see where the leak starts because you can see those nighttime flows. You look at the bottom of the curve, look at what you see underneath, and you can see you got everything stable up before August 13th. You got a pretty stable night flow. And then all of a sudden something happened, and you can see the usual thing with leaks. They get worse over time. So what starts as around 40 cubic meters per hour, again, you can see on the left, by the time it's fixed, it's around 55 cubic meters per hour over roughly a 10-day period. So we actually provide this service now to the Port of Halifax and others on a fee-for-service basis. So we do charge a monthly fee to monitor their system for them. But I want to tell you that the water that was lost in that one leak paid for the service for the whole year. So that was good value for money. So Port of Halifax are very happy with us. They can look at their own leakage, and we can look at their leakage. So both of us can look. So here's a simple installation. Again, you're getting to see that standard RTU panel. We got this standard approach. We have the same thing for all of our meters. So you can see that little advertisement there for SCADA pack, but nonetheless, it works very well. That's the remote terminal unit that we'll then take up and hang up in a telephone pole. You can also see a large meter there. This is actually a turbine meter to your left and a positive displacement meter to the right. So this is actually a compound meter you're looking at here that goes into the port. And here's a lovely screenshot of a leak that was picked up through that meter. So many of you might think the leak actually is in the light blue. So I'm going to tell you, no, not really. The light blue is kind of the normal flow that you see on this screen. You can see some diurnal repetition there. And then, of course, when the leak happens, the positive displacement meter basically maxes out. It can only flow so much water, and you see it maxes out there. And you can see that consistent flow in the middle of the screen, that nice light blue. That meter is absolutely maxed out. That's that smaller 2-inch positive displacement meter. most of the leakage, of course, is going through the turbine down below. So there's a different scale, and that's why you had to be careful to point that out. The green is a different scale than the blue. But you can clearly see down there in the green, that turbine is howling water through that meter. So the good news is the port did indeed go out and fix that meter. And not fix the meter, but fix that leak. And often they've actually used Halifax water crews to help them find the leak, which is another fee for service that utility can provide. Okay, so last but not least, I'll spend some time now with pressure management, because we talked about the pressure leakage relationship earlier and how important it is to control pressure in your systems. It is definitely one of the key strategies that has been promoted by the AWWA water loss control methodology. If you reduce pressure, you will reduce breaks, and you'll also reduce background leakage. And of course, there is absolutely a direct relationship between pressure and the amount of leakage of a pipe. And I'm going to show you that very clearly with these next few slides. So here's a leak under pressure. This is a leak that was dug in the Halifax water system. Now, we did throttle the valves a little. We still were allowing it to leak a little bit under control, because this is a bit of research that Halifax Water is doing. So we were shutting down, just had a little bit of water still going into the main, and dug up the leak. And this did not service, by the way. You should be aware this was actually an unreported leak. It was leaking into the nearby storm sewer and getting away. So here it is under pressure. As now we turn down the valves to make them tight, the water is now starting to drain towards this leak, and you can clearly see there's less leakage. And as the water starts to drain even more, there's not much more pressure now at this site, and now we have a little trickle. And soon there'll be no water, and our crews will then go out and actually put a clamp actually around this. They did not actually have to cut this pipe. They simply put a repair clamp and then flush the main, disinfected, and put it back in service. So you can clearly see the relationship here with pressure. So very important that we manage pressure. And there are several ways you can manage pressure, but probably the most common is the fixed outlet control. And this is still tried and true, and this is very useful for utilities to use this methodology. It's basically using either a diaphragm or a piston type pressure reducing valve to set a downstream pressure below that downstream of that valve to control pressure at a constant rate. Very useful, often used throughout the world. But now there's new ways. We can also now control pressure through what we call flow modulation. We can allow now the downstream pressure to trend with the flows. So as pressure goes up, we can allow the flow to go up with it. As pressure goes down, we can drop with it. So we can actually now manipulate our systems so we don't allow excess pressures, in particular in the nighttime. For those who know, pressures naturally creep up at nighttime, so we can learn to control those and drop the pressures when those flows are lower. We're all going to do a better job with leakage control in our utilities. The good news is a lot of research has been done with this, and Halifax Water actually was part of a leakage management technologies project with the Water Research Foundation, where we put together a prototype to show how this could work. So here's the research project. So again, here's that pretty picture you saw earlier with all the different colors, the sizes and shapes of our DMAs. And here's one we're going to focus on called Dartmouth Central. So I'm going to blow that up now. You get a closer look. Again, it's a little bigger DMA than most. It's about 60 kilometers of pipe. And this is what we would refer to as a cascading DMA. So in other words, it's got feeds coming into the DMA and it's got feeds going out. So at the top of the screen here, you'll see two feeds going in. One's called Lehman and the other one is called Micmac. So these are the PRV chambers where flows come into the zone, which is of course isolated from the other DMAs nearby. And you'll see down the bottom of your screen, three areas where water leaves this DMA through the Albro PRV, Elmwood PRV, and the Wise Road PRV. And there's also a note there about a critical node, and that is of course an area where we're very keen to make sure we have pressure. We've got a school nearby, and also it is the high point of the system. So we're going to be paying particular attention about any pressures at that area when we're doing our research. And you'll also see something called an AZP. That's another monitoring location that measures the average zone pressure. We'll also pay attention to that as we're doing our research. So here's the prototype that we developed, and we've since changed this to use other technologies, but this was basically showing how we could manipulate a PRV to do what we wanted it to do. So we, of course, programmed through a programmable logic controller, a PLC, and we've got a controller here that manipulates the pilot of the pressure reducing valve, which you can see at the bottom right-hand corner. There's a PRV in the bottom right here, and you'll see to the very left a bias chamber on the pilot. So you look at the very left, you'll see a nice brass instrument there, a flat plate that's pushing down on the pilot. That is where we manipulate the PRV. So we make the PRV do what we want it to do. So as flow changes, we manipulate the PRV to trend with it. So in the nighttime in particular, if the flows are low, we then allow the pressure, we want to push the pressure down and set a new standard for pressure downstream. So now I'm going to show you a graph. Being an engineer, one must show you graphs. So here's the most important, I guess, diagram here for pressure management that you need to see throughout the entire presentation. So we looked in particular at night flows. Again, I talked about how important night flows were. And in the interest of research, we did something that you shouldn't do, but we allowed our system to actually be totally open to the upstream pressure initially with no pressure control. So that's the way we started this nice piece of research here. We actually had a fixed control PRV in place, but we actually just took it off and let the system do what it was going to do. So you can clearly see, if you look to the left-hand side, this is, and again, let your eyes adjust a bit. What you see in blue is pressure. What you see, I think, in orange or red, depending on your screen colors, is flow in terms of a volume. So you can clearly see on the left-hand side here what happens at nighttime. You can see the mark very clearly in that first quadrant. And you can see the PRV is absolutely doing its thing. It's absolutely doing a great job. Fixed, it's got a fixed PRV setting, so the pressure is the same. And then you'll see the pressure changing as we take off the pressure control. Obviously, pressure increases. If we take off, we have no control. The volumes, it doesn't matter what's going on with the volume to a certain extent, pressure is going to go way up. And you can clearly see what happens at nighttime here. You see the first example of no control. At nighttime, we have 103 cubic meters per hour as our leakage or usage, what the flow under the curve. And you can see where pressure has gone to the highest it could go, dangerously high. Luckily, we did not have a break that night. We did have crews on standby in case we did have a break. We were ready to go, but luckily, we did not. So again, we did this in the interest of science. So I always tease the audience again, do not try this at home unless you're ready for a problem. So then we put back the fixed control, and you can clearly see it's doing its job nicely. We've got absolutely a consistent downstream pressure. And we now with fixed control, what we see at nighttime is now 79 cubic meters per hour. So a definite improvement, obviously. The biggest improvement from no control. And then we go to flow modulation with the third type of control. And we see now we get down to a night flow of 70 cubic meters per hour. And what's nice to look at is you can see the pressure dip compared to where it was the night before with fixed control. So now we've brought it down now to a very nice, manageable level. A lot of people aren't using water at night, so people aren't complaining necessarily about pressure. We only had one person who worked night shift that called us up and said he noticed a little bit less pressure in his shower. But once we explained what we were doing, the person was okay. Said, well, that sounds pretty interesting. But you can clearly see from this how you use more refined technology to improve your pressure management capabilities within a utility. All right, so in summary, why do we do water loss control? Well, really, it's the ultimate in what we'd call triple line results, triple bottom line results. In others, it's got social implications, economic implications, and environmental implications. Starting with, it's very cost effective. At Halifax Water, we started with an infrastructure leakage index of 9, reduced it to 2.5, and saved approximately $650,000 per year in electricity and chemical costs. Basically, that's the money that's spent in the treatment plants and the pump stations that boost your water around your system. And that's pretty much at our economic level of leakage. We might be able to squeeze a little bit more, might be able to get down to 2 with more refined tools, but it'd be very difficult to get below 2, should we say, at an economic basis. It does improve public health protection. Always remember that we're in the public health protection business, more so now than ever with COVID. We must have clean sanitation and access to clean water in order to really help combat COVID. We all recognize a leaky system is prone to contamination. There's a lot more potential for backflow into your distribution system if you've got a very leaky system. So that is a social aspect. You'll have better, healthy community with a good leak detection system. It improves the level of service to your customers because now we're finding leaks in a proactive manner. We often go out and find a leak, then knock on customers' doors and tell them we're going to repair it the next day. And they say, well, we don't see a leak. And we say, well, you don't, it hasn't surfaced. We found it. We're going to dig up the street tomorrow. Please fill up your bathtubs, draw off some water. But rest assured, we'll let you have your breakfast. We'll come with our crew in the morning. We'll have it fixed before you come home by supper time. And sure enough, that's often what happens. So customers love it. They're very appreciative of having that level of service. And we tell them we're going to shut the water down and work with them to keep them informed. It also reduces liability to a water supplier. There's been lots of lawsuits, more perhaps in America. As we all know, there's more lawyers in America than probably any country in the world, and we won't say much more about that today. But there's been lots of lawsuits around destruction of public and private property. And if you can show that you're using the latest methodologies, you will certainly stand up in a court. And I can say that Halifax Water did exactly that. And I was there actually to give testimony when we were actually sued in a court of law. And I was always pleased to tell people that during the proceedings, the judge actually referred to me as a reasonable man. And I like to explain to people that when a judge calls you a reasonable man, you're having a really good day. That's a wonderful thing when a judge calls you a reasonable person. Last but not least, leakage recovery often stands as the best source for new water resources for systems facing shortage. So like we saw with Pignon in particular, if they can get their leakage under control, it means now they can provide service to a greater population of their community. So that is a wonderful thing when you can get that benefit to provide service to more people at actually a cheaper cost. It is much more expensive to look for new supplies than it is to curtail leakage and make that capacity available for new customers. Some of the lessons that we learned about this methodology. You saw a lot of technology. Yes, technology does play a part, but there's a lot more at stake here. It's about change management. It's about trying to do something different. And we had to have a lot of time with our staff to convince them that this was a new methodology and that we were going to try something different, because we were tired of, I guess, digging a hole and not getting anywhere with it. So as your mother and father always said, when you're in a hole, you should stop digging. So we stopped digging and we took a different approach. You need project champions, and I say often plural. You need more than one that are very enthusiastic about this and will actually lead the initiative. And we look for those leaders in every utilities, and I know the folks that are listening today, you have them in your utilities, and hope that they'll step forward and really embrace the methodology and bring everybody along with them. You should involve as many people as possible. This is one of those great methodologies and strategies that you need to involve many departments, and the more the better. You need to involve your distribution system, your treatment plant folks, your meter department, you need to have your customer service folks on side, and you need your finance department on side. Everybody's got to buy into this new methodology. And it's a wonderful thing when you get everybody to buy in, because you also bridge these silos when you start to respect each other's services that you provide utility, and you get breakthrough results as a result. Not an easy thing to do, but that's really a big piece of the change management, getting your corporation to buy in. Now in Halifax Water, we actually use it as a corporate strategy to get people to buy in. We actually had targets that we set for our organization around water loss control, and we rewarded our staff when we reached our targets. And this is the last point to make. You should measure performance. So how do you know you're doing a good job? And once you know you're doing a good job, then by gosh, you have an obligation to celebrate your success. I'm a firm believer that you should celebrate and reward the success that you achieve. So Halifax Water, we did some fun things. When we first started, as you see here on this graph, we had an infrastructure leakage index of 9. So in 1999, we started with an infrastructure leakage index of 9. So we were losing a lot of water. And today, we have an infrastructure leakage index of 2.5, which represents the capture of roughly 40 million liters per day of leakage. So I'm going to repeat that. 40 million liters per day of leakage. That is indeed a lot of leakage. So to show our staff that we're very appreciative of their efforts, I can remember I told staff that if we reached an ILI of 4, we would throw a barbecue. So you see that little burger there in 2003-04, we hit the ILI of 4. I threw a barbecue. I put on the chef's apron and flipped burgers and had a great time. And as usual at these events, I get to say a few words as the general manager. So I gave them my usual pep talk, but I explained to them that we weren't finished. I said we had to at least get to a level of 3, because I felt an infrastructure leakage index of 3 was world class. We wanted to be world class. So of course there was a person in the back of the room. There's always a smart aleck that likes to talk a lot in the back of the room, and that's good. You want to encourage them to have a chat and some camaraderie with the troops. And he called out from the back of the room and said, "Okay, Carl, what will you do for us if we reach a infrastructure leakage index of 3?" So being a good general manager, I replied back and said, "What would you like if we reach an ILI of 3?" And the gentleman called back and said, "We'd like to have a lobster boil." So I said back to him, "We'll make it so." So we reached a level 3 ILI, we boiled lobster. And I had the pleasure of going out and boiling up lobsters and feeding the crews again for their fine performance. And that continues today, is methodologies to reward performance for success. So with that, merci beaucoup. And I'm very pleased that I had your attention for, I guess, a little over an hour today. And I'll stop sharing, I guess, at this stage.
Thank you so much. That was such a fascinating presentation. And I'm sure, I hope we have questions from our participants.
Yes, I see a few comments on the side. And if anybody has a question, please, perhaps you can go through the chat box so people can see it. And then I'll do my best to respond. I noticed a little comment, first of all, from Madeline about providing more information around our noise mapping application, and certainly I can do that. That's been an excellent methodology that many utilities have adopted now based on our experience. And of course, if anybody has any questions afterwards, I should also provide my email address. And I don't mind if people want to write it down now, but I'm sure Ignatius can be kind enough to provide that as well. But my email address is carl.yates@gmail.com. So that's Carl with a C, C-A-R-L, Doug, D-O-U-G, Yates, Y-A-T-E-S, @gmail.com. And I also believe we can make this presentation available to you folks as well. We may have to put it in a PDF, however. I'd suggest doing that because it's probably going to be a very large file. I think it's around 8 megabytes at least. And some of those transition photographs that I've got are rather, I guess, data hogs. But perhaps I can turn into a PDF, maybe Ignatius, and send your way. Maybe that might be the simplest thing, and then you can provide it to participants.
We are also recording this presentation, and we're going to upload it and share.
Oh, great.
Yeah.
Even better. Yeah, so people can see some of it. Yeah.
I see that Jeff, you have a question. Please proceed.
Okay, good afternoon.
Hi, good afternoon, Jeff.
Yeah. We spoke about, well, Mr. Yates spoke about DMAs for leak detection. My question is for countries like Dominica, where we have our systems already existing and they are not so neatly tied where we can isolate areas and form DMAs. How would you deal with those type of systems?
Yeah, certainly there's a couple approaches I would take. If it's possible, certainly to install DMAs in the distribution system. That's my first recommendation, which is not necessarily easily done because in many cases you may have to install new valves. You may also have to turn off some valves to make sure that the DMA is truly leak tight, because that's a challenge in many systems to actually have a leak tight DMA so that you actually are truly isolated from your neighboring zones, because that is the only way you can really detect if you have got leakage, within the zone. If you've got leak through, you won't be able to do much, I guess, useful review of nighttime flows in particular. So it's going to cost some money, but we can often make the case, as I showed during the presentation, where you can break up one big DMA into 3, and we actually had payback over a 2-year period. So that was a really good investment, for 2-year payback for that kind of money. I think we had 5 meters that we installed at $25,000. That's $125,000 and got payback in 2 years. That being said, if you can't, install DMAs, the leak surveys using the noise mapping technique also can be used. So if you've got people trained with the ground microphones, you can go listen to all of the appurtenances attached to your distribution system. Things like, valve caps. You can even flip over a valve cap, a valve box, and go right down on the operating nut and listen to the valve and see if you can hear any noise. You can listen on curb stops, corporation stops. You can listen on hydrants. So any place at all that you've got an opportunity to make a metal connection to your distribution system, then it's an opportunity to do so. I will want to point out that it is easier to find leaks in a metal system than a plastic system. So if you do have plastic systems, I will say it is much, much more difficult to pinpoint leaks using ground microphones.
You have a few questions in the chat room, Carl.
Yes, I saw one there from Madeline about having a change management, I guess, dedicated person on staff. Now that's an interesting question. We certainly brought in change management, but we made everybody take ownership. So right from the top, from myself down to the supervisor, we gave them basically the opportunity to make any recommendation for change they wanted to. So we did not turn away anybody's idea. So we got everybody involved, and everybody came up with great ideas. That was the thing. And we rewarded those ideas. I should point out as well that we did have some incentives for individual performance for people to reduce leakage. And we had people turning over every rock to find not only leaks, but illegal connections. I can say that we found quite a few illegal connections And those are the best ones to find because that's revenue water. That is worth a lot more than a leak. So there was wonderful things that happened by getting more than just one change manager involved. We had, at the end of it, we had so many champions. I used to say, if I tried to stop water loss control, they would simply walk me down to the wharf and throw me in the ocean, and I'd be done. They would actually get rid of me. I couldn't stop it. It was so embedded culturally. So everybody took ownership because it was a corporate initiative and backed by myself and everybody on the front line. Okay, so we're here talking about active or passive pressure management. And which one do you recommend for Caribbean islands with 50% leakage on the distribution system? Okay, well, I would tell you to take a holistic approach, certainly still with that amount of leakage. The good news is there's a lot of low-hanging fruit there, but certainly I would start with ordinary pressure-reducing valves. I showed you the advanced technologies using flow modulation, but I would suggest using the ordinary pressure control valves, which are either what we call the diaphragm type or the piston type. Both can work. We've used both. I can say the diaphragm perhaps is a little more sensitive during low flow. The other thing that's important is to install as many meters in your system as you possibly can. There's nothing like meters. You also saw where I said if you can measure it, you can manage it. So when I say meters, if you can meter your customers, that's wonderful. And if you can also put the big master meters in your distribution system, that's also wonderful because you can see where the big water is going and you can focus then on the priority areas, chase the big water, right? And the low-hanging fruit. So that's, I'd still take a very active approach with a 50% loss. And like I say, there were certainly utilities in Canada that had similar leakage problems. The city of Montreal probably is one in Canada that had some of the worst leakage history, and I'm pleased to say they've started to tackle their problem.
I think Madeleine was asking whether, I think it's in the chat, you could see it there. Sorry.
Yes, she made a comment about culture, and that's really where we are today. We started, by the way, with a big committee. Surprise, surprise. We formed a committee at our utility when we first started water loss control. We had representation from every department. We had a lot of key leaders in the room that were setting the bar for everybody to perform. But because we embedded a culture of accountability deep in the organization, a committee does not exist today, which is amazing to think about, right? We have no committee today because it is so embedded in our standard work practice now, we don't need a committee. It is now culturally entrenched in our utility. So
okay.
it's,
There's another question about, well, the question is whether you would be okay with providing a copy of the template spreadsheet with respect to noise mapping notes to the participants through us. To CAWASA.
Yeah, I can certainly show you. I mean, the nice thing is you can see that on the screenshot that I had there. That's a great example, right, of how to document, but it's basically an Excel spreadsheet. So it's not, that's the nice thing about it. It's not fancy. Everybody can use most people can use an Excel spreadsheet. And the supervisor keeps a track of all the noises that are turned in by the leak detectors, puts it in a spreadsheet, and then makes sure that they're followed up to do rechecks and coordinate repairs. So it's something that's really straightforward for any utility to adopt. So that's why we liked it so much. It was simple. We started with something really simple. That was one of the first tools we actually used to find the low-hanging fruit. So if there's nothing else that you do, train your crews to find leaks and fix them and go out and keep at it. And then you can bring in your other tools later, like DMAs and pressure management.
Well,
one of the things with working with Haiti on this project, and Madeleine can speak a little bit as well as Carl, because they're both on the Haiti team, but we're going to be working with them over a very extended period of time to reduce their water leakage, which started off at 90%. They're at 84, I think, between 80 and 84% right now. So there's a lot of opportunity there to really do something drastic in Haiti. But one of the things that we're working with them, and we'd love to send some teams now, because of COVID we can't, but we're looking at doing training with them, showing them how to do the leak detection. So putting a program together, and Madeline on our board is with a lady called Aisha, who's the general manager of Houston Water, or a manager at Houston Water. They're putting together the knowledge capture. So we're going to be developing standard operating procedures, videos, and this isn't just going to be used in Haiti. We're going to be able to offer these to other places. So that's, you know, coming. We're not there right yet, but we've started this process. And I don't know, Carl or Madeline, you want to add a bit to that as to what we're doing there and how that can be shared?
Maybe I'll just step in briefly. Aisha and I, as Valerie mentioned, will hopefully be working with the folks who are doing the leakage detection and helping build what we're calling a knowledge base, so that they have an investment. As Carl was mentioning, it's so important to build a culture. And one of the cultures that you can help with is developing your skills, your competencies at collecting your basically knowledge. So, and it helps with succession planning if you have an older set of staff. That's all. It's a longer story. We're going to pilot this, and so we're feeling our way. And the idea is that we're going to hopefully be able to then apply it to other districts, and having learned from the first group.
What
Carl,
part of Haiti are you doing this?
Pignon.
In Pignon.
Oh, okay.
Yeah, Carl mentioned it actually in his slides, I think, didn't you, Carl?
I did, yes, indeed, yeah. I guess I'm glad that Madeline mentioned this. This is a long-term process, and that's why I want people to understand you need to have some patience, because, you know, a lot of the upfront investment needs to be made. You need to train folks, you need champions, and you need to stick at it. You can't give up early. And but you'll see, you know, it takes time, and you can see that in the Halifax water case. You know, it took 10 years to get where they are today. Think about that, right? That's a long period of time. You know, they've been at it for 20, but it took 10 years to get the mature state that they are at today. And I often tell people, you know, doing leakage control is like doing the laundry. It's never done. So don't think you're going to find some end game. You're not going to find it. You're going to always be at it. And that's a good thing, because that's the payback, the fact that you can stay at it and keep it at a manageable level. That is the absolute objective.
I'll just mention and add to Carl's comments about change management. The reason I had the question about whether there was initially a dedicated person is sometimes that can help. You know, when you're starting a new initiative and it's change. No matter what you think of it, it's change. And so you want to manage that as well. And so sometimes having a person or two to help develop that culture that you obviously did wonderfully will be a useful thing to think about, you know, when you're budgeting and starting the whole thing.
Yeah, perhaps I should be careful to say, you know, that we had everybody, you know, really dedicated to change management. But I should point out that obviously, you know, it was a passion of mine, the stem leakage, and we had a real reason to stem leakage. And, you know, there's that also adage you often hear when people say, what your boss finds interesting, you should find fascinating. So I think that was a case for me when I made it very clear to people that I was actually fascinated with it. So they actually had to take it a game up beyond that. So they had to basically be zealots of water loss control. They had to be you know, more than fascinated. They had to be totally over the top. And they were. I mean, we had a lot of superintendents and operations staff that once they got started, I was just amazed. I just had to give them the resources and get out of their way, because they were on a mission. And that's what we hope will happen in many utilities yet throughout the world.
But sometimes it's a mixed bag, you know, and you do inspire, Carl. Absolutely, you do. So just because I've been on a few projects where, you know, yeah, you got one or two people, but you don't always have it at the start. You need to develop that.
Yeah, we were lucky. We did actually have a lot of people out of the gate. Well, a lot of people were frustrated because we were tired of looking at the traditional North American approach. And, you know, with what we call the approach of looking for unaccounted for water. Well, that just sounds like an awful term to start with, right? It means you don't know what you're doing. So we were pretty frustrated initially, and once we found this new methodology, people said, we're going to give it the college try, and we went at it.
So I see a comment in the chat box from Neil.
Yeah, there's a comment in the chat box from Neil Esprit. He says that's a wonderful approach, Carl. You get the culture going before the actual system. So there is an organic, may I say, drive towards awareness of leaks and leak repairs. And after introduction of systems, there should be more eager participation and get the snowballing improvements in leak detection and repairs. Thank you.
Exactly. And get the early wins. And the good news is, when you start, I mean, you know, with like Pignon, there's a lot of low-hanging fruit there. You know, the only direction they can go is up. They can only improve. So God bless, we'll be working with them and hopefully see some great improvements over time.
So I have a question for Carl, because in the Caribbean, you know, there are hundreds of, you know, bursts in the system every month on a national system. When you've detected the leak, where's the cutoff where you repair or replace? How do you do that?
Yeah, you can certainly do an economic evaluation of the cost of replacing a section of main versus you know, repairing it. You know, I can use an example in Halifax. Our average cost to dig and repair a main would, you know, and they're not cheap because you have to have traffic control and all the things that go with it. It's probably, you know, around $5,000 to repair a leak. Okay, so you can see that, you know, over time, if you've got a leak-prone section, you can do some quick calculations to figure out that, you know, at some stage it pays to just simply replace it. Now, there's other things that do come to bear, and that is customer expectations. Often we can see mains replaced before they actually reach that, should we say, economic level that they should be, because there's also, I'll say, you know, I don't want to use the necessary or say word direct benefits that you can measure, but there's certainly tangible benefits if you don't, should we say, destroy the street, disrupt traffic, shut down businesses, shut down schools, torment your customers, make them aggravated because they're out of water. That's worth something. So we often do surveys of our customers to ask them what they think of our service. And we also benchmark that. So we're careful to walk that triple bottom line. It's not all economics. There's a social aspect, and then there's also an environmental aspect. And here's an example where we'll replace a water main sooner rather than later. If we have a water main that breaks near a river, and that water, of course, contains chlorine, and it kills fish, then we're going to be looked upon very poorly as environmental stewards. So if we've got a water main near a river, we're not going to allow many leaks before we fix it. Again, looking at the environmental repercussions. So every time we look at something, we look at it through that lens of economics, social aspects, and environmental stewardship, a triple bottom line approach.
Yeah, Carl, I'm glad that you mentioned these, and I know that in our parts in the Caribbean, as I circulated to the registrants about giving them an overview of the course, one of the things I said is in the region, we average near 50% non-revenue water. And the governments are now, through our discussions at the high-level fora, at the Caribbean Water and Wastewater Association conferences, increasingly there's a greater awareness about water loss control and water loss management. And now some of the policymakers are now saying to their utilities, well, we are not going to give you any new money for improving your water systems. You got to go and find it in non-revenue water. But now you are saying to us that this is a more medium to longer term process because you have to stick at it. It could be over 10 years. And I was just getting some of your more comments on this.
Yeah, I think that's important for people to realize that, you know, you still need some financial help in a lot of cases, because you know, there is an investment to be made in capital and in training to really set yourself up for success. And that's the thing, right? There's an upfront investment that needs to be made. And sometimes utilities don't have that money. So they can, you know, sometimes they can get loans. If they can get access to finance, then that's good. I know sometimes there's turnkey contracts that some companies will take. They'll actually upfront the money and find the leaks and then recoup the money afterwards. In other words, it's a performance-based contract. We've seen many companies come in and do that in different areas of the world. We've seen it in the Philippines. We've seen it in Brazil. Seen it in South Africa, in Australia. Seen it in many different countries have chosen that method as well, to bring somebody in on a performance-based contract to do it. Now, in the end, you still need to have, however, the cooperation of your local utility to make that work. But I always think it's much better if the utility can do that work for themselves, because once that contractor is gone after the 10-year contract is up, then that technology, you know, that there's no transfer of knowledge. Then that leakage can come right back, and it often does. You know, sometimes these contracts are for a fixed period of time. Leakage is brought under control. Contract's over. They decide not to renew, so we'll take it from here. But yet, there's not been that transfer of knowledge. So, I believe if the utility takes ownership, gets the knowledge, gets the training, it is a much more sustainable approach, because it goes beyond their generation. It then keeps on going to the next generation, and you get better intergenerational equity as a result. You're doing a better service to your customers, really, in the long run.
Well, and what you've talked about very convincingly is ownership of and responsibility for that system. You know, they're invested, which is
absolutely
terrific. Yeah.
There's nothing like pride in an operations that finds leaks and keeps them under control. I can tell you it's a badge of honor. I mean, I often refer to our leak detection crews as the paratroopers of our organization. We drop them in, and they're on a mission, and they will find those leaks, and they bring it back, and they have a big grin on their face when we dig a hole and find a small leak for fixing.
Right. I think we have done pretty well. I mean, you have stayed with us for more than 90 minutes now, and that is very good, because the conversation has been very good. There are some nice takeaways. I think you said that what your boss finds interesting, you should find fascinating. and if you can't measure it, which is a good management always saying, I think Druck has said it as well. If you can measure it, you can manage it.
Absolutely.
And we don't want to get, I like the one on the customer partnerships with the one you did with the cruise ships and the utility and Port of Halifax. And I think you did some considerable work in your presentation on pressure management, which is critical to that process. And I think some of the incentives you gave to your team for the infrastructure leak index, reducing it. So these are all good takeaways. We want to thank you immensely for giving us your time this evening, and for the participants who joined us today. As I said, this has been recorded, and we're going to share the recording with all the participants, and we will put it up on our Facebook page and our social media for those who missed it and for future posterity. Thank you very much, everyone. Thank you.
Thank you.
And
I'll be pleased to go earn my supper. It's now supper time in Halifax, so I'm very pleased that I've earned my supper, and I shall go have a great time with my wife and my two dogs.
Thank you very much.
So
Thank you.
Ignatius, just for the participants who are on the line, we are partnering with Operators Without Borders with the CWWA in putting on a preventative maintenance workshop, which is normally a one-day workshop. We've split it into 2 3-hour sessions, and that's going to be held on October 6th and 7th on, you know, what does a preventative maintenance program look like, and very specifically getting into all of the details on that. So that's going to be a workshop that you'll be getting information through CWWA.
Yeah, appreciate it. We will be following that, and you can send us the link so we can share
Will
with
do.
our partners. I would also like to inform participants here and those who will be following this page that our next session is going to be on the 30th, and that's a webinar number 16 on groundwater, and that will be presented by the Secretary of the CWWA, Ms. Candice Santana. So we look forward to seeing you next week, Wednesday at the same time. Thank you, everyone, and have a good evening.
Thank
Au revoir.
you. Bye-bye. Thank you, Carl.
Thank you. Au revoir.
Au revoir. Merci.